Hello guys, in this video we are going to be looking at principle of flotation. In our previous video we saw upthrust, and we can see here that the principle states that an object floats in a fluid. Remember, a fluid can be a liquid or gas when the weight of the object equals upthrust. Okay, another way we can say that is that a floating body displaces its own weight of the fluid in which it floats. So that means that the weight of the fluid is equal to the weight of the liquid that is displaced. Okay, so obviously we have this W equal to U. That means weight equal to upthrust. Now the weight of the object is mass of the object, or mass of solid, times acceleration due to gravity. But the upthrust is mass of the liquid displaced times acceleration due to gravity. That's upthrust, the mass of the liquid displaced times acceleration due to gravity. Now both can now be rewritten as thus. Since mass is density times volume, we have this. Okay, so mass of the solid is density times volume. So we can say that weight of a solid is equal to the density of that solid times the volume of the solid times acceleration due to gravity. That's the same thing with upthrust. Upthrust is the density of liquid times the volume of solid immersed, okay, then times acceleration due to gravity. Okay, so if the weight is equal to the upthrust, then we can say that the density of solid, volume of solid, acceleration due to gravity is equal to density of liquid or fluid, okay, volume of solid immersed times acceleration due to gravity. So here we can see that G cancels this. That gives us a formula. Now from there we can also have that that the volume of solid immersed all over volume of solid is equal to the density of solid all over the density of liquid, which is what we call the fraction of solid immersed. That's exactly what we have here. So that means if you are asked to calculate the fraction of solid that is immersed, it is simply density of solid all over the density of the fluid, or the density of the liquid, as the case may be. Okay, so what are the conditions for object to float? Now the first one is that the average density of the object should be less than the density of the fluid in which the object has to float. Okay, now for example, a ship is very heavy but it floats because its hollow inside it contains air. This causes the average density to be lower than that of water. Okay, that's important. Now the second condition is that the upthrust force of the fluid on the small object must be equal to the total weight of the object, which is the principle of flotation. For example, a coin will sink to the bottom when placed on the surface of water. This is because the upthrust on water on coin is less than its weight. That's important to know. Then thirdly, the volume of objects submerged must be large so as to displace large amounts of fluid. Okay, that's another condition. Of course, that's another example here is the ship. You know, the hollow makes it displaces water that is equal to its own weight. The volume must be large so as to displace large amounts of fluid. Now, an object of density 0.75 grams per cm cube floats in a liquid of density 1.25 grams per cm cube. What fraction of object was immersed in the liquid? We say that the fraction of object immersed in a liquid is VSI, that means volume of solid immersed all over the volume of solid, okay, which actually is the same as the density of solid all over the density of the liquid. So here we have that the density of solid is 0.75 and we have that the density of the liquid is 1.25, okay? That's the same thing as 775 over 125, okay? So I think 25 can go here 3 times, then 25 can go here 5 times. So the answer to that question is 3 over 5, or you say 0.6. Here we have a ship of mass 1.2 times 10 to the power 6 kilogram floats in a sea water. Okay, that's the mass of the ship. What volume of sea water does it displace? So in this case here, we are going to assume here that the volume of seawater is the same. The density of seawater is the same as the density of water, which is 1000 kilogram per meter cube. Okay, so here we already know that the mass of solid times acceleration due to gravity is equal to the mass of the liquid displaced times acceleration due to gravity. Okay, now since we're asked to find the volume of the seawater displaced, we can write this as, okay, remember this cancels this, so the mass of solid now is equal to the mass of liquid displaced is density of the liquid times volume of solid immersed. Okay, or volume of liquid displaced. Never forget that volume of solid immersed is the same thing as volume of liquid that is displaced, which is what we are asked to find. So that means the volume of solid immersed is equal to the mass of the solid, okay, divided by the density of the liquid in this case. So the mass here is 1.2 times 10 to the power 6. Now divided by the density of the liquid, which is density of water, is 1000. So that is going to give us 1200 meter cube as our answer. Okay. Now here we have a cylinder of mass 70 grams, weighs 30 grams in water. Now if the area of the cross section is 5 meters squared, its length would be, okay, from here, if it weighs 70 grams in water, that can give us the mass. So we can say the mass in air is 70 grams and the mass in water is 30 grams. Okay, so that means the upthrust, which is the mass of water displaced, the mass of water displaced now, which is the upthrust, is equal to 70 minus 30, which is equal to 40 grams. Okay, we can convert this to newtons by dividing by 1000 and multiplying by 10, or you say divide by 100. So if we divide by 100, it is going to give us 0.4 newtons. Okay, so the upthrust is 0.4 newtons. Now, since we are given that the cross-sectional area is this, remember the condition for floating, okay, is that the weight here must be equal to the upthrust. Okay, so the weight is not given here, but we know that it is density okay, the upthrust is equal to the density of the solid, of the liquid, times volume of the solid that is immersed, times acceleration due to gravity. But in this case, we are not given the volume of solid that is immersed. Let's erase this. So that means we can still write that upthrust here is equal to density of liquid times the volume of solid immersed can be area, okay, times length. Volume is area times length, okay, times acceleration due to gravity. So that means the length now we are looking for is going to be upthrust all over density of the liquid times area, cross-sectional area, times acceleration due to gravity. So the upthrust we just got is 0.4 divided by the density of the liquid is 1000. The cross-sectional area is 5. Acceleration due to gravity is 10. Okay, so that will give us the answer that we are looking